G'day. Well, it's a pretty wild old day outside, and yeah, we're back talking about this thing that I'm about to make or experiment with. Today we're looking at the coil, the pulsing coil, that will be pulsed with DC pulse. In order to make this coil, however, there's a few things we need to know. We need to know the Gauss of the magnet, we need to know the diameter of our bolt and the permeability of our bolt. We also need to know how big our wire is, the diameter, and that will determine the size of the coil and how many turns we do. Once we've done that, the rest of the coils that we put on there have to be exactly the same as that coil. That is to say, the same ohms, I think you would say. Pretty sure that's correct. So the same length, the same amount of turns, and the same ohms. Anyway, so let's have a look at the Gauss of the north. Is about 4,000, just over 4,000 Gauss, as you can see. That's the first thing. Second thing is, what is the diameter of this bolt? And the permeability of that bolt, I believe, is about 100. That's really carbon steel, what carbon steel is. So I'm just going to say, without knowing exactly, I'll just say 100. That's the standard. And we can see that our wire is 0.33 of a millimetre. 16.4 mils it's saying there, but with the tape, without the tape, I'm happy to say 15 mils, so we're going to go with that. Now my intention is to pulse the coil with extremely high voltage DC with a 50% duty cycle to start with, see how that goes. Let's have a good look at this. Now, in order to pulse the magnet, the coil, and then negate the flux of the magnet, you can see that it's got to go from north to north. So that means that coil is going to have to be wound in a north manner. And the way to do that is the thumb rule. So what you do is point the thumb in the direction that the north has to face, and the direction of the winding will follow your fingers. So for example, it's got to go that way. Therefore the windings have to go around clockwise if you're looking at from this end. So now, just one other thing that I have to tell you about this is that I'll aim to make this an LC resonant circuit, so we'll get more bang for our buck when we come to pulsing the coil and negating this north flow of the flux. Now we're going to head inside and hit up AI for all the information, and we'll find out how big a coil we need. So here I've already had quite an in-depth chat with ChatGTB, and yeah, found out a whole heap. And amongst other things, ChatGTB, whatever it is, ChatGPT reckons it's feasible. And here is some complex math that the ChatGPT has gone through to actually determine how many turns of a coil was required. And I was just guessing when I plugged in the information for this one, but for the real one, let's do it now. So finally, here is some of the math that the ChatGPT did to find out how many turns, and it turns out we need about 480 turns. I don't know if it's going to be, if it's going to need that many. That's maybe overkill. But anyway, a little bit of the math shown here, and we will just play around, I think. We might switch to ferrite core, better in induction, and so we'll need less turns. But anyway, good to know. Thanks for watching, and catch you later.